Good afternoon, my dear students. Welcome to one more amazing session from Infinity Learn by Sri Chaitanya. Good afternoon. This is Suresh, Faculty of Chemistry. How are you, my dear students? Hello, Vanga Annamani. Good afternoon. And we are in NEET STEP UP 2025 program. In this NEET STEP UP 2025 program, we are offering physics, chemistry and biology sessions right from 12 o'clock to evening 6 o'clock, which are on YouTube platform. We are providing all NEET lessons based on this YouTube platform and related to absolutely NEET syllabus. And we request you guys follows the regular sessions and you just like, share and subscribe with our NEET STEP UP 2025 YouTube platform. Good afternoon, Irfan Patel. How are you, my dear students? Yeah, you say POBC, what is that? Irfan Patel, how are you? Good afternoon. And we are into a session in a week in a chemistry. First 3 days we are giving 11th standard syllabus and the last 3 days we are going to give 12th standard syllabus. You are going to get an electrochemistry in one shot. We already completed electrochemistry in the previous sessions. As many of the students are requesting for electrochemistry और एक session देने का पूछ रहे हैं, so that today we exclusively given electrochemistry in one shot. Getting ready with that. That's good, my dear students. UV, hi, good afternoon. Good afternoon. Oh, very good. So coming to the electrochemistry, in the entire NEET examination paper आपके लिए कम से कम ये क्वेश्चंस इलेक्ट्रोकेमिस्ट्री चैप्टर से सीधा आना संभावना है and related to electrochemistry and electrochemical series and the reactivity orders, it may be linked to other inorganic chemistry topics, so that ये particular electrochemistry chapter बहुत important है आपका NEET examination में. So it is logic oriented. इतना कॉम्प्लिकेटेड कॉन्सेप्ट में आपका इतना सरल करके आपका सामने एक 90 मिनट्स क्लास में एक वन शॉट में देना चाहता हूं. तैयार है? एक बार एक थम्स अप एंड फायर इमोजी डाल के शुरू कर सकता हम कर सकते हैं. राइट, वेरी गुड टू सी हियर. एंड द टोटल इलेक्ट्रोकेमिस्ट्री, आई जस्ट वांट टू just give the major topics. First one is galvanic cell and electrochemical cell, and the second one is electrolysis, and after that electrolytic conductance, and after that corrosion and batteries. These are the major 4 areas where electrochemistry preparation you need to plan according to that. Got it, beta? Yes, Ishita. Remember electrochemistry हम खत्म किया एक बार और एक बार रिवाइज करने को मैं कोशिश कर रहा हूं क्योंकि सब लोग इलेक्ट्रोकेमिस्ट्री के बारे में पूछ रहे हैं चैट बॉक्स में. गुड आफ्टरनून इशिता, हाउ आर यू डूइंग? सो रीनीट, ओके, रीनीट, ओके, मेनी जजमेंट्स, सो स्टिल इट इज इन पेंडिंग. सो मैं क्या बोलना चाहता हूं, यू जस्ट ये बकवास को छोड़ के आप नीट 2025 में तैयार करने का अच्छा होगा. ओके, सुरेश कुमार, गुड आफ्टरनून, great to see you guys. So very good number of students are in the queue right now. Okay, so without any late we'll start galvanic cell. तैयार है एक बार? Right. Okay, अभिनव आया ना अभी तक? Okay, so let's start with galvanic cell. So galvanic cell and electrolysis, electrolytic conductance and corrosion, these are the 4 major areas. You can strike a question from NEET examination, my dear students. Here you can see this is your galvanic cell. In this galvanic cell, zinc rod is immersed in zinc sulfate solution, copper rod is immersed in copper sulfate solution, and they are connected by using a voltmeter or a galvanometer, and these 2 separate vessels are connected by using a salt bridge. We are going to discuss about what is that salt bridge even. And ये galvanic cell में क्या चल रहा है, क्या क्या रिएक्शन है. So we are going to see what are the reactions. The reactions that we can see in this galvanic cell, my dear students. Suresh, you are there in the previous session, you are not coming regularly. Is electrode में zinc, this is an anode, this is anode. In this anode zinc is going to be losing electron and it is going to give zinc 2 plus. And the loss of electron, what do you call it as oxidation? जहां पर oxidation होता है ये anode होगा, क्योंकि ये इलेक्ट्रॉन रिलीज कर रहे हैं ना, इसी का कारण ये वाला नेगेटिव चार्ज बन गया. सो नेवर एंड एवर रिमेंबर एनोड इज अ नेगेटिव एंड कैथोड इज अ पॉजिटिव. इलेक्ट्रोलाइटिक सेल में ये उल्टा भी हो सकता है. सो जिस इलेक्ट्रोड का ऊपर आपका ऑक्सीडेशन चल रहा है ये एनोड है, जहां पर रिडक्शन चल रहा है ये कैथोड होगा, है ना बेटा. दैट्स वेरी इंपॉर्टेंट. एंड कैथोड हो रहा है आपका कॉपर सल्फेट में कॉपर 2 प्लस तैयार है, एक्वियस. ये जो इलेक्ट्रॉन ये निकल रहे हैं ना, ये एक्सटर्नल सर्किट से बाहर जाके ये कॉपर इलेक्ट्रोड को पहुंच रहे हैं. यस, नो प्रॉब्लम जाही. So this copper 2 plus is going to take these 2 electrons and become, it is a copper which is in the solid state, and the electron is absorbed. So electron gaining process, what do you call it as a reduction process. So overall reaction is going to be electron lost, electron gain. The overall reaction is going to be zinc in the solid state and copper 2 plus in aqueous gives rise copper which is in the solid and zinc which is in the aqueous state. So this is the overall reaction. When you see, as the time goes on, mass of the zinc is depleted. As the time goes on, copper mass is going to be increased over here. So mass of the copper is increased. Got it? So this is what the overall reactions that are taking place. Jahi, is that fine? Right, Ishita, got it? These are the major reactions, and the IUPAC representation that is given as zinc solid and zinc sulfate aqueous, and these two are separated by an electrode. Yes, and copper sulfate is giving rise to copper and an electrode, and these are separated by a salt bridge. What is this salt bridge? We are going to see in this upcoming session, upcoming slides. We can see here. Now, so direction of the flow and direction of the current. So electron flow is in this direction from external circuit. Conventionally, according to physics, current is going to be flow in the opposite direction. Okay, fine. That's good. Very good. Now IUPAC representation. The IUPAC representation is given. Zinc metal is converted into zinc 2 plus, and a metal and electrode is given as a vertical line. Here copper 2 plus is converted into copper, and these two are separated by a salt bridge. Salt bridge is indicated by using two vertical lines. Got it? Fine. This is the IUPAC representation. Based on this IUPAC representation, you have to decode the actual chemical reactions like this. When you decode it, you will understand how to use Nernst equation as well from the questions. So this is very, very important. And left hand side LHS anode is written, and RHS cathode is written. That is anode and cathode basically are separated like that. And we'll see what is this salt bridge. This salt bridge is U-shaped vessel, U-shaped glass tube. This is your salt bridge. So this is your salt bridge, and this salt bridge contain salt. What are the salts? This contain salt along with water, dissolved salt in water, so that they can go for the conduction. When you fill the aqueous salt and invert it, salt is going to flow down. To avoid that, this is mixed with the semi-solid material, that is agar gel. आपका जस्ट जेली चॉकलेट का आता है ना, and just like you eat an agar just jelly chocolate like that, so that the ions are going to be used here. So what happened here? So zinc is losing and it zinc 2 plus is formed, so that positive charge is increased. In that, salts like potassium nitrate can be used, potassium chloride can be used, so that this is neutralized by depositing nitrate ion from this. And however, the electrons are coming like this, electrons are coming, they have to be neutralized. To make it neutralize, you have K plus. Like that, electrical neutrality is maintained and the circuit is being completed. And very important point for a NEET examination, my dear students, NEET examination, and what type of salts that can be used to make it salt bridge. So the ionic mobility of the cation, ionic mobility or the speed of the cation should be equal to anion. That is the speciality. So if you know it, you can crack a question from NEET examination. Hope you are all understanding this concept, right? So it is a electrochemistry in one shot. Therefore, I just want to give this explanation in a rapid way, so that in 90 minutes total electrochemistry you are going to learn, and you are going to revise, and you are going to get the formulas related to total electrochemistry, so that this NEET examination preparation is going to be awesome, right? So prepare like a pro, and you're just going to write the examination like a pro, and you're going to get the result in an excellent manner, and you will be a topper. So what I want to say, please every day attend the sessions without any fail, so that you just see how the faculties, eminent faculties in front of you from the Infinity Learn Studio and on YouTube platform delivering the lectures, and ये lectures को फायदा उठाने की कोशिश करो, so that you please like and share with your friends, like these sessions and share with your friends and subscribe to the channel. So coming to function of salt bridge that I already mentioned, what is SRP and what is SOP. And what I want to say, when this galvanic cell is working, this galvanic cell, it is spontaneous redox reactions that are taking place, and generation of electromotive force is taking place. Now what I mean to say, why zinc is giving the electron, why copper is taking the electron? That is the major question you need to inculcate. So from the question itself we are going to rise in the subject, है ना मैडम? And so when a metal, मान लो यहाँ पर जिंक है, जिंक सल्फेट में डाल दिया, when the zinc is immersed in zinc sulfate, it experiences some potential that is called single electrode potential, and the copper is immersed in copper sulfate, it experiences some potential. And when you compare these two potential, a electron देने का संभावना इसका ज्यादा है, इसका कम है. So when you compare these two potential values, electron potential of the zinc and zinc sulfate is more. So that is what I want to say, that is what you can say single electrode potential, electrode potential. This electrode potential is when a metal is immersed in its metal sulfate or metal solution. So it experiences some potential, okay, that potential is called electrode potential at 298 Kelvin at 25 degrees centigrade, 1 atm pressure. When this molarity is equal to 1, that is what you call it as standard electrode potential E0, standard electrode potential. So I mean to say a metal loses electron and it gives rise, this is what you call it as oxidation. So for that it is called as oxidation potential, or you can also say it is M and Mn plus. It is called as standard oxidation potential. Standard oxidation potential. You can just take the reverse process also. Loss of electron is called oxidation, and oxidation process के लिए standard oxidation potential होगा, and उल्टा करके लिखो reduction होगा. So reduction में क्या, ये Mn plus takes n number of electron gives rise M, है ना. In this process, this is what you call it as standard reduction potential. That is equal to, ये process उल्टा दिखाना पड़ता है, that is called standard reduction potential. So मान लो हमारा ये जिंक है, जिंक का एग्जाम्पल लेके आपको दे दूंगा मैं. So zinc loses zinc 2 plus and 2 electron. मान लो इसका E0 value of this zinc and zinc 2 plus, okay, और zinc 2 plus and zinc, इसका होगा zinc 2 plus and zinc, and its value is experimentally found to be 0.76 volts. Its value is minus plus 0.76 volts. And one thing I just want to say, magnitude is same, but the sign is reverse. That's the reason why I just want to say SOP is reverse of SRP. Okay, it could be minus, it could be plus. If it is plus, it could be minus. Got it? So that's very, very important. And it is absolute value of this is cannot be determined. Okay, ये absolute value निकालना बहुत मुश्किल काम है, क्योंकि ये difference निकाल सकते हैं. Okay, for that we need a reference electrode, that is standard hydrogen electrode, normal hydrogen electrode. So what is this SRP? And this is what you call it as SRP value, and this is SOP value. हर electrode का SOP SRP होगा. And ये खतरनाक ट्रिक है. This is very important. And the total inorganic chemistry is based on this. If you open S block, if you open P block, it will be given for the first page electronic configuration, atomic number, ionization energies, atomic radii, everything will be given. At the last, electrode potentials will be given. That electrode potential values is this. If SOP value, standard oxidation potential value increases, tendency of the oxidation increases, and it is reducing power increases. If you know this logic, your total inorganic chemistry in your hand. Mind it. This is very, very important for NEET examination, my dear children. Ishita, is that fine? Got it. Very good. So let's see. So if SRP value is increased, and it is going to be the reverse, right? So tendency for the reduction increases, and it is going to be the oxidizing power increases. Got it? Yes. And measurement of electrode potential. I said absolute value of the electrode potential never be measured, but we can take with reference to hydrogen we can take. So it can be measured by using some electrode as a reference electrode. Abhi filhal hydrogen electrode is the primary reference electrode for measuring the single electrode potential. How it is designed. So a standard solution of hydrogen, you can say this is a platinum black, this is your platinum. So this is your platinum electrode, and it is immersed in 1 molar HCl, and it is kept 25 degrees centigrade and 298 Kelvin, and hydrogen gas is pumped through it. So that what happen, it is going to be in equilibrium with, Hu3O plus means Hu plus, and takes an electron, and it is going to be hydrogen, and this is at equilibrium. When this is at equilibrium, its standard oxidation potential or standard reduction potential is going to be 0.0 volts. So this is what you say, arbitrarily this value is taken as 0, and with reference to this 0 value, all electrode potentials are constructed and they designed and gives rise a tabular form. The tabular form, what do you call it as? Electrochemical series. So we'll see all the projections here. So electrochemical series. So application of electrochemical series gives you the actual order of the reactivity of the element or the metal or the non-metal, everything. So the arrangement of the electrodes in the order of increasing and standard reduction potentials is called electrochemical series. This is also called as activity series. You can say electrochemical series, ECS. And if you understand the ECS now, majority of the questions you can crack it from NEET examination from inorganic chemistry. It is true. You can do it the best. Okay, let's see. So the chemical reactivity of the metals. So the metal that has, you can see here, so hydrogen, electron, it gives rise hydrogen gas. Its value is 0.0 volts. You can say fluorine, take an electron, F minus, and its value is taken, and lithium takes an electron and it is going to be lithium. So highest reducing power is attributed to lithium and highest oxidation power is attributed to fluorine. So we can say oxidation power increases and reducing power increases. So this is the basic thing you can know from the electrochemical series. So I am going to tell you all these things, how to use this. Okay, so the chemical reactivity of the metals, and the metal that has a higher negative value of standard reduction potential, SRP value, is it readily loses electron and it is converted into a cation, and they are going to be the strongest oxidizing agent. And also relative strength of oxidizing and reducing agents, and the fluorine is having the highest oxidation agent, and lithium is having the strongest reducing agent in the periodic table. That is electron giving tendency. In terms of electron giving tendency, in terms of electron taking tendency, it is given from the electrochemical series. Got it? Fine. Now, and this is your electrochemical series. I just want to give this in 2 stages. So lithium, potassium, calcium, sodium, magnesium, aluminum, zinc, iron, cobalt, nickel, and later you can see tin, hydrogen is taken as a reference. Okay, and the copper, iodine, silver, mercury, bromine, chlorine, iodine, and the fluorine is the strongest oxidizing agent. Got it? Clear? And here Google form is given in the chart box and also in the description box. My dear students, you please go through this this Google form, and also we have given this in the description box. The Telegram channel, you all join in this Telegram channel so that सारा का सारा क्लास का नोट्स आपको PDF फॉर्म में मिलेगा, आप कर सकते हैं, अच्छा तरफ कर सकते हैं. ओके, यकीन रखो, अच्छे तरफ अभ्यास करो, अच्छा कर सकते हैं. ठीक है बेटा. नाउ डिस्प्लेसमेंट ऑफ हाइड्रोजन फ्रॉम डाइल्यूट एसिड्स. जो मेटल्स है ना, ओके, so those metals which are present above the hydrogen can displace hydrogen from mineral acids. When they are present, the metal present at lower of the hydrogen cannot displace the hydrogen from the mineral acids. That's the reason why you can say zinc can react with HCl, H2SO4, gives rise dilute H2SO4 and gives rise hydrogen gas, whereas copper do not react with H2SO4 to gives rise hydrogen gas, rather it going to give the sulfur dioxide. Understand? So that is the simplest thing you need to know. Study the table, don't by heart the table. You need not have to memorize any value here. Every value will be given in the question itself. Question itself value will be given. Are you getting or not? Clear? That's good. Fine. Now, so standard EMF can be calculated. So many formulas are there. You just take this formula into the action and you can revert it. So EMF is equal to E naught of the SRP of cathode minus E naught of SRP of anode. So this is a powerful formula. You can make it as a cheat sheet. Got it? Any doubt? Dear students, you can ask if you have any doubt. Ishita, Suresh Kumar. Yes. Now, let's see one more. So, as SOP increases, tendency of oxidation increases and reducing power increases. As SRP increases, tendency of the self reduction increases, and it is going to increase the oxidizing power. And this is the, you can make it as a formula or the mantra for total chemistry, not only electrochemistry, inorganic chemistry, physical chemistry, organic chemistry. This is the fact, right? And okay, some questions we'll see later, right? Nernst equation. So, why copper, gold are used in inert electrodes? Copper is not used as an electrode, Suresh Kumar. Gold are used as an electrode. Rather, platinum is used as an inert electrode and nickel is used as an inert electrode. And graphite is used as an inert electrode, not regularly copper and gold. Okay. Inert electrode means the electrode which do not react with the electrochemical reaction. They do not involve in electrochemical reaction. You can use the inert electrodes. Yeah, inert electrode means you can say, as it is do not react means you can use graphite, carbon electrodes, you can use platinum electrodes, right? Is that fine? Suresh, now let's talk about effect of concentration and temperature on electrode potentials is explained. Yes, namaste, you are late, Abhinav. You are late. Okay, but sometimes never we use it. Okay, sometimes we can use where it has no reaction in a particular reaction, that you can use it, but there is a huge chance of side reaction. So we मेरा ख्याल में कि नहीं होगा. Suresh Kumar. Okay, right. So for a metal electrode, for a half cell reaction, कर दीजिए, माफ कर ली, हर दिन माफ करना है क्या? All clear, that's good. Now let's say Nernst equation for the electrode reaction. It is given for m, n plus, takes n number of electron, becomes m, and the electrode potential is given as m 2 plus and m, or n plus here, let it make it n plus here, is going to be E as standard electrode potential minus RT by NF ln m upon m plus. So if you take this value, R value 8.314, temperature value 298 Kelvin, and F value is of Faraday 96,500 coulombs, you are going to concise this as, you can say, this is the equation you are going to concise. Here this E naught Mn and M standard reduction potential, R is a gas constant 8.314, and T is an absolute temperature, N is the number of electrons involved in the reaction, and F is 1 Faraday, 96,500 coulombs, and on pure liquids and solids the gases is at 1 atmospheric pressure and molar concentration is taken as unity. Mean to say here molarity is taken as 1, and if you put all these things here and you are going to get for single electrode potential, and it is given as 2.303 RT by NF logarithm to the base 10 1 upon Mn plus. You can use E naught Mn plus of M and minus 0.059. So if you put all the values now, its value and F value. So it is going to be 0.059 upon N log 1 by Mn plus. You can use it for our galvanic cell like this. For the reaction of Daniell cell, zinc solid plus copper 2 plus aqueous gives rise zinc 2 plus and the copper. You are going to get LNQC. So that you can say EMF or E cell is equal to E naught minus 0.0591 by N and log QC reaction quotient. We are connected to equilibrium again. So ये reaction का QC क्या होगा? Reaction quotient आपका होगा and zinc 2 plus and copper and zinc and copper 2 plus. जहाँ पर आपका solid आ रहा है ना, वहाँ पर value 1 लेना है. So इसका value 1 होगा, इसका value 1 होगा. So 1 का वजह से QC value कितना होगा? QC is equal to zinc 2 plus and copper 2 plus. So that आपका ये वाला E is equal to E naught minus 0.0591, okay, and it is going to be N is equal to 2 log zinc 2 plus and copper 2 plus. That what I want to explain you here in this slide. Got it? Yes, that is. And at equilibrium QC is equal to Kc, and it is going to be the relation between equilibrium constant. At equilibrium constant, reaction quotient is equal to equilibrium constant QC. So if you put that is equal to cell at equilibrium is going to be 0. A value 0 dal K 0 is equal to E naught cell minus 2.303 RT by 2 log Kc, and you can also use E naught cell is equal to 2.303 RT by 2 log Kc, क्योंकि ये रिएक्शन का n is equal to 2. n वैल्यू क्या बोल रहे हैं यहाँ पर? आप सीधा सा बोल सकते हैं ना. Yes, n value is the number of electrons that are involved in the oxidation and reduction term. Total number of electrons that are involved in redox. ठीक है? Okay, right. So this is the Khatarnak equation. You can get it from, you can calculate Kc from this equation. In general, for any equilibrium, for any cell, E naught cell is equal to 2.303 RT by NF and log Kc. This is an important, you can directly calculate. Yes. Okay, कुछ बोलना चाहता हूँ. Now you can say log Kc, and you can calculate Kc by taking the anti-log from this. ठीक है? So you can calculate from this electrochemistry, from equilibrium constant, everything is related to, interlinked to this electrochemistry chapter. Fine, beta? Now, so you can also say E naught cell, yes, is equal to 0.0591 by N log Kc. What is N? What is N? N is the number of electrons that are involved. Or log Kc is equal to N E naught cell upon 0.059. You can take 0.06, you can approximate it. And maximum reversible work. The relation between the delta G and the cell constant. Okay, now here it is equilibrium constant and EMF. For a process, if delta G is less than 0 or negative, the process is going to be spontaneous process. Spontaneous process. If delta G is equal to 0, that process is at equilibrium. And if delta G is greater than 0, the process is going to be non-spontaneous process. So this is connected to thermodynamics, my dear students. This is connected to thermodynamics, yes. So according to thermodynamics, delta G is equal to minus NFE cell, or delta G naught is equal to minus NFE naught cell. Delta G gives free energy change. N is the number of electrons that are involved in the redox change, and F is going to be the constant, and 96,500. E cell is equal to EMF. So NF is the charge of N mole of electron passed for this electrode. Okay, so I just want to say delta G values are additive, and EMF values are not additive. That's very, very important. I am going to show you in the next slide also. So let us consider the silver electrode, and it is about the solubility product. So when silver iodide takes an electron, gives rise to silver and iodide. So this is at equilibrium, and equilibrium silver iodide has a solubility product, and the solubility product can be related to the EMF. So this is related as I minus AgI slash Ag, and it is going to be, this is a metal insoluble salt soluble ion electrode. Now in this electrode potential between Ag plus and Ag is equal to E naught of Ag plus and Ag minus 0.0591 by 1, because when electron is taken, N is equal to 1. This meant N is equal to 1, right? That's good. And it is log 1 by Ag plus. This is one expression that you can say for a single non-metal and metal electrode. And also for this reaction, Ag plus and electron gives rise Ag at equilibrium. So here you can say E naught of I minus slash Ag, salt bridge and Ag, it is going to be E naught of this minus 0.0591, okay, upon 1 log iodide concentration. You got silver concentration, you got iodide concentration, so you are going to get the solubility product for the reaction of this. So you can, since Ag electrode is going to be minus 0.0591 log 1 by Ag plus, you are going to get I minus is going to be this much, and that I minus this electrode is going to be, it is not clearly shown here, right? It is going to be Ag plus dot I minus. Got it? So soluble, that is your nothing but solubility product for the silver iodide. If you remember, AgI gives rise Ag plus and I minus. So Ksp is equal to Ag plus and I minus, है ना? So you can directly put Ksp over there. Yes, that is Ksp. So you can calculate solubility product constant, ionic equilibrium from the electrochemistry. So the electrochemistry is a core subject, core topic. It is connected to inorganic chemistry, it is connected to chemical equilibrium, it is connected to ionic equilibrium, it is connected to spontaneity and thermodynamics. So what not, that's the reason why this chapter is such an important chapter. You need to connect it so that you can do 180 out of 180 in the NEET examination. Tayar hai? Ishita, Richa Sharma, Abhinav, Richa Sharma is there in the class? Yes, you're all ready to do that. एक thumbs up दे, एक fire emoji दे class में. सब दे सकते हैं ना? हाँ. Yes, very good. Now, if a E naught cell for a given reaction has a negative value, then which of the following gives the correct relationship between for the values delta G naught and K equilibrium. ASR, AR, who is that? Okay, okay, who is that ASR, AR? नाम क्या है बेटा आपका? इसका आंसर क्या हो सकते हैं? चार्ट बॉक्स में फटाफट आंसर देना, चार्ट बॉक्स में आंसर देना. अरे आंसर दे निशिता, अभिनव, Asrar. So if I remove the underscore, no, something I have to decode your name. Fire, आग लग रहे हैं. Yes. Now ASR, AR. What is your answer? Kavina Kuch. For a given reaction has a negative value, E naught value is negative. Okay. So I just option 2. You want to say option 2? Yes, you can say if E naught cell value is a positive, if E naught cell value is a negative, if E naught cell value is 0, it is equilibrium. Okay, E naught value negative, cell don't work, and E naught is positive, cell works. Cell works. Okay, so it said that E naught value is negative, means cell doesn't work. If cell doesn't work, means its delta G value is negative or positive. It's non-spontaneous. It is. You came late. Okay. Okay. Anyways, we'll go with some other questions. So this is your option 1 is the correct answer. So theory examination. So however, physical chemistry means you feel it is a theory or numerical. So need not be a physical chemistry need not be always numerical oriented. Rather, it is going to be a theory and logic oriented. है ना? So a logic के हिसाब से ये question होगा. And talking about concentration cells, whenever concentration cell is same electrode and condition is E naught is equal to 0. Now I just want to say for concentration cells, you have electrolyte concentration cell and electrode concentration cell. In the electrolyte concentration cell, concentration of same electrolyte with different concentrations are taken, whereas electrode concentration cell, you will take the gaseous species, the partial pressures are different over here. So that is the difference between the electrolytic concentration cell and electrode concentration cell. समझे? And of course this concentration cell सिर्फ NEET का complicated question अगर पूछेंगे तो आएगा. Okay, it is not at the difficult level. More than difficult level these questions are can be asked. है ना बेटा? Yes. Yes बेटा, how are you? Right. So let's see thermodynamics of the cell. Thermodynamics of the cell. So we know that delta G is equal to minus NF E cell. Here it is saying that entropy delta S is equal to entropy change. So entropy change is given as NF dE by dt, and that is what you call it as dE by dt. You can say temperature coefficient, mind it. Okay? Yes. Now, in that Gibbs free energy and the cell potential is given as delta G is minus NF E cell and delta G naught is equal to minus NF E naught cell. Wherever I am making a circle, that is a formula. You all write these formulas at a side so that before going for the examination, you can just 10 minutes you can revise these formulas and आराम से अंदर जा सकते हैं examination का, so that you can have the quick look at that. So that is how the simple answering of the questions can be done. Now you can say delta G is negative, delta G is positive, delta G is equal to 0, and it is the case where delta G is equal to 0. Status क्या? The process is at equilibrium. Where a delta G is negative, it is going to be spontaneous. And Okay, let's go with electrolysis. So this is your electrolysis. It is a non-spontaneous process. Passage of electricity through aqueous solutions or molten state. The compound is decomposed into its constituent elemental substance. That is what you call it as the electrolysis. And electrolysis, delta G is going to be always positive. It is a non-spontaneous process. Got it? And you can get the electrolytic, the vessel, what you are saying, that electrolytic cell, and the electrolyte what you use, the solution you use, electrolytic solution, and the one which is cathode and one which is anode. यहाँ पर cathode जो है ना, ये negative charge का है, ये positive charge का है, anode बन गया. So how do you say cathode and anode? Wherever oxidation takes place, that is anode. Wherever reduction takes place, that is what you call a cathode. That is the simple way, and that should be the way according to IUPAC representation. So you can say aqueous solution. When you talk about aqueous solutions, the electrolysis of aqueous solution follows the preferential discharge theory. According to the preferential discharge theory, if more than one ion is available during electrolysis, the one which has the more mobility and the easy tendency to get deposited, and that will be deposited. For the order of cathodes and positive ions, the order is going to be sodium plus, magnesium 2 plus, aluminum 3 plus, H plus, and copper 2 plus. More likely to be discharged is this one, right? And for the negative ions, sulfate, nitrate, OH minus, Cl minus, Br minus, I minus, this is more likely to be discharged. So that is the way you need to know. This is actual trick. This is actual trick. Now let's see electrolysis by using inert electrode. Electrolysis by using inert electrode, you can say copper chloride molten by using graphite electrode, inert electrodes. So what happened? Copper chloride gives rise to copper 2 plus and 2Cl minus. So at anode, Cl minus loses electron and gives rise chlorine gas. At cathode, so it is going to be copper 2 plus and 2 electron and gives rise to copper. So copper is deposited at cathode and chlorine is liberated at anode. So that is by using inert electrolytes, and it is molten. If it is molten state, let us see the aqueous state. Copper chloride, aqueous by using graphite, right? Or you can say copper sulfate or sodium chloride. Let us talk about the sodium chloride. Sodium chloride gives rise sodium plus and Cl minus in the aqueous. You are going to get H plus and OH minus. So at anode you can say Cl minus and OH minus. You can say Cl minus comes more likely than OH minus, so that I just want to give the chlorine as a priority. So Cl minus loses electron and chlorine gas is formed. Whereas at a cathode you have H plus and Na plus. H plus is going to be reduced to give rise hydrogen gas. So that at cathode hydrogen gas is deposited, at anode chlorine gas is liberated. So this is how you need to, okay. So I just want to say whenever inert electrodes are there, this is the preferential discharge theory, you need to use it. While You can see electrolysis by using active electrodes. Electrolysis by using active electrodes. Active electrodes means, okay, one of the student initially asked one question based on this. Who is that student? Come on, who is that student? Active electrode means the electrode which react in the electrochemical reactions, right? You can say copper sulfate by using copper electrode. So what happened? It is nothing but copper electrode, and this is anode and this is cathode, and copper sulfate is taken. So when the electricity is passed, carefully you observe, copper is going to dissolve in at anode, so that at anode copper dissolves at a cathode the same copper is going to be deposited. So that copper 2 plus 2 electrons gives rise copper. So what happened? The mass of the anode decreases. So it is going to be like this. Mass of the cathode increases. So this is the principle that we use in the electrolytic refining of the copper. Got it? You all got it? Any doubt? Good. So this is electrochemistry in one shot. So आधा पहुंच गए हम, आधा पहुंच गया है ना? Right. So laws of electrolysis, Michael Faraday is given the Faraday's laws of electrolysis. According to this first law, the mass when the during electrolysis is happening, when the current is passed through the electrolyte, certain substance is deposited at cathode, certain substance is deposited at anode. So the amount of substance that is deposited at a particular electrode is directly proportional to the quantity of charge that is passed through the electrolyte. That is given as Faraday's laws of electrolysis. So the mass of the substance that is deposited is directly proportional to the quantity of the charge passed. So that is going to be M is equal to EQ. So E is equal to electrochemical equivalent. You can say Q is equal to CT. So you can use the direct formula M is equal to ECT. Okay. So that formulas you can use directly to give the calculations based on this. So this is a super power formula. So the weight of the substance that is equal to electrochemical equivalent current time upon 96,500. That's very, very important for Faraday's first law के यही formula weight in grams. Electrochemical equivalent is the unit that is nothing but the amount of substance that is deposited when 1 ampere current is passed through the electrolyte for 1 second. Okay. So number of moles can also be calculated. NEET में ये formula सीधा इस्तेमाल करो इशिता. So that is going to be N is equal to IT by N factor into 96,500. सुरेश कुमार, ओके कोई प्रॉब्लम नहीं, धीरे से बोल सकता आपको, क्योंकि ये सेशन इलेक्ट्रोकेमिस्ट्री के वन शॉट का है ना, सो इसीलिए इतना जल्दी बोला. कोई प्रॉब्लम नहीं बेटा, आपको समझ में आ रही क्या ना? Okay, Suresh. So you are with my name, you can rock like anything, huh? Rocking, huh? Rocking or not? Ishita, you are rocking? Rocking in the subject. So make a note of it. Jaldi make it. Yes, thank you. Next, so let's talk about the Faraday's law, second law. When dilute H2SO4 is taken as an electrolyte, copper sulfate in an electrode and AgNO3 in the electrolytic cell. So here the amount of the substance that is deposited, hydrogen here, copper here and silver here. So the amount of substance that is deposited at a particular electrode when they are connected in a series, according to physics, when they are connected in a series, we are offering to provide equal amount of charge is passed through the series of electrolytes. In that case, the amount of the substance deposited here and the amount of substance deposited here, the amount of substance deposited here are in the ratio of equivalent mass of hydrogen, copper and silver. So I just want to say, so equivalent mass of the A, B, C, you can say here amount, weight of substance of hydrogen, weight of substance of copper, weight of substance of silver are in the ratio of equivalent weight of hydrogen and equivalent weight of copper and equivalent weight of silver. So simple, it is very simple, it is very simple. This is what second law of Faraday of electrolysis. Clear? So we come across with first law, we come across with second law and there is no third law. You want to discover third law, that's up to you. Right, beta? So Faraday was a scientist. He has given Faraday's law of electrolysis and also some laws in the physics. So let us not discuss about that. Okay, talking about second law we discussed. Okay, conductance. The third point is going to be conductance. So electrolytic conductance and electronic conductance. Electronic conductance is about physics and electrolytic conductance we are talking about here. So we just want to say resistance R is equal to rho by LA. So that L is the length and A is the cross section. So R is called specific resistivity. So that specific resistivity is equal to RA by L. You know the conductance is equal to 1 by R, the reverse reciprocal of this. So that specific conductivity is equal to 1 by rho specific resistivity. So rho is equal to, you just take 1 by rho is LA by 1 by R. Right? So that is the formula. That is the formula. This formula you can use it. This formula you can use it. So wherever I am making is a box now, that is a formula. Suresh Kumar, fine. Electrochemistry in one shot, mind it. You are going to get an excellent presentation. Excellent presentations. Fine. Now let's talk about molar conductance. The molar conductance means here the specific conductance. This is called specific conductance. I just want to say the conductance offered by the conductance offered by 1 cm cube electrolyte is what you call it as a specific conductivity. Let's talk about molar conductance. So the molar conductance means when the conductance offered by all ions in 1 mole per liter of the solution. One mole per liter electrolyte. So जब molarity 1 mole per liter आएगा ना, that is equal to specific conductivity into 1000 by molarity Siemens centimeter square mole inverse. Namaskar Parvaz Kha. You came late. You came late, my dear student. So we are in NEET Step Up 2025 program, my dear student. You please be on time and be punctual and be regular. Every student, we are discussing here electrochemistry in one shot, so that you will be having a rock solid concrete basement for the NEET examination preparation, my dear students. You all just get advantage of these sessions, है ना बेटा? Right. So let's see equivalent conductance. So जब concentration normality में निकलेगा ना, that is equivalent conductance, the conductivity offered by 1 gram equivalent of an electrolyte is dissolved in a liter of solution, that is called equivalent conductance. The specific conductance into 1000 upon normality, and sure, definitely we can take it, definitely we can take it. आगे है कुछ, है ना बेटा? Because time is also constrained now. Let me give the concept first, let me give the questions. So we'll be, if required, Suresh, we'll do one thing. Questions related to rapid multiple choice questions on electrochemistry. One session निकलेंगे, we'll do it. So if you have some inputs, give it to me so that we'll execute it. आपका तरफ से, सिर्फ आपके लिए, आपका नाम के ऊपर दे सकते हैं सुरेश कुमार, है ना? Some suggestions also followed. Whatever you type in the chat box, that is going to be discussed. Yes, yes. Kachiravan, Logvanayagam, yes sir. Arey, chat box, use chat box. Logvanayagam, use chat box, so that we will come to know what you want, na? So I do, more than your name, I don't ask anything, na? We are not asking money. So paisa kamane na kai kar rahe kar mein. So we are doing something for the students' benefit, है ना? So I want to see all the students who on the chat box should be active, nothing more than that, right? So I am going to keep a questionnaire, multiple choice questions, and standard PYQs, standard model of the electrochemistry chapter and all physical chemistry chapters. I am going to keep it, right? Yes, that is. So now let us talk about effect of dilution. If dilution is increased, molar conductivity increases, specific conductivity decreases. And one more important thing, if you see root concentration and molar conductance, so there is increase in the molar conductance as dilution is increased for potassium chloride, strong electrolyte. Okay, steady increase. You want to go for the weak electrolyte, the acetic acid, it is going to be like this. It is going to be like this. So there is a sudden increase and there is a gradual increase. Got it? That's very important observation you need to know. Gradual increase, sudden increase. You don't study the graph like this, study the graph like this, because root concentration. So root concentration is increased, root concentration is decreased. Root concentration is decreased, it means dilution is increased. So as dilution increased, molar conductivity is increased. Molar conductivity is increased. Got it? That's very important. And Kohlrausch law of independent ionic migration. My dear students, you can calculate molar conductance of a strong electrolyte by extrapolating the graph, but weak electrolyte you cannot do so, it is going somewhere infinite. So for that we need the Kohlrausch law. What is Kohlrausch law? So A, B is an electrolyte, gives rise A plus B minus. Let's say here CH3 COOH on dissociation gives rise CH3 COO minus and H plus. Right? Now molar conductance of the infinite dilution for CH3 COOH is equal to ionic mobility of CH3 COO minus plus ionic mobility of H plus. So sum of the ions, ionic mobility is equal to total molar conductance. At infinite dilution, when ionization is complete, each ion migrates independently and contributes to the total molar conductivity. That is what you call it as Kohlrausch law of independent ionic migration. So this is given as alpha can also be calculated. Alpha is degree of ionization, that is equal to molar conductivity at given concentration and molar conductivity at zero concentration, that is called limiting molar conductivity. Right, that's very, very important. Yes, Ishita, fine. Now batteries, the last point that we are going to discuss about this chapter is batteries. So battery is an example of a simple galvanic cell, portable, and where chemical energy is converted into electrical energy, so that we can connect that into the mobile phone and the laptop and the car whatsoever. Okay, batteries. So the batteries, primary cells, the primary batteries are the batteries where the electrochemical reaction, once it is completed, it is completed. So once you use the battery, you can just throw it, that is wall clock. So it cannot be reversed, the electrochemical reactions cannot be reversed. Okay, so that is called primary batteries, so only once it can be used. So example is dry cell. So commonly used dry cell is what you call it as a Leclanche cell. So let's talk about the Leclanche cell. So the dry cell consists of zinc container. This is your dry cell. Every day, Nippo, Novino, Duracell, these are all the dry cells, where you can see a carbon rod and ammonium chloride paste, zinc cap, manganese dioxide and with a carbon black. Okay. So what are the reactions that takes place in the dry cell? So these are the reactions that takes place in the dry cell, where zinc is oxidized and ammonium manganese dioxide is reduced. Okay, so that overall reaction is taking place like this. I just want to say here, whenever the battery is even not used, because of this ammonium plus is always active, the battery is drained continuously. However, the battery is not used. So this is about Leclanche cell, and let us talk about the mercury cell. The mercury cells are used in the watches, hearing aids, and car remote controls. This mercury cell is used. Okay, so the mercury cell, this appears like this, where the reactions takes place. Zinc in alkaline medium gives rise zinc oxide, and mercuric oxide gives rise mercury. So the speciality of this reaction, in the overall reaction, there is no aqueous media. Whenever there is no aqueous media, it provides the constant voltage. That is the speciality. Mercury cell gives the constant voltage. That is a logical oriented subtopic here. NEET examination में इस्तेमाल करो ये point सीधा, है ना? So one problem is that overall reaction कैसे निकलते हैं समझ नहीं आ रहा, क्योंकि ये ओवरऑल रिएक्शन में दो इलेक्ट्रॉन्स निकला, दो इलेक्ट्रॉन्स इस्तेमाल किया. ओके, सो दैट H2O लिक्विड इस्तेमाल किया, निकला. सो जो बचा है वो लिखना है. सो OH माइनस एंड OH माइनस, सो दैट जिंक ऑक्साइड, मर्क्यूरिक ऑक्साइड, मर्करी. बस समझे सुरेश? समझे? हाँ, वेरी गुड. क्लियर बेटा? नाउ लेट अस टॉक अबाउट सेकेंडरी बैटरीज. अब सेकेंडरी बैटरीज आता है ना, यस, दे कैन बी यूज्ड रिचार्ज्ड. सेलफोन जो बैटरी है ना रिचार्ज कर सकते हैं, कार का बैटरी है ना रिचार्ज कर सकते हैं, है ना? यस. हाँ, ये कैसे नोट करो कॉपी में, टेलीग्राम चैनल में आपका आएगा ना ये नोट्स पूरा. Let's talk about lead storage battery, or you can also say it is a lead accumulator. So let's see, it's a reversible. हर chemical reaction secondary cell में आप reverse भी कर सकते. Okay, that's very important. This is your lead accumulator used in the cars. Okay, so you can use oxide, amaran. Now you can see the cross section of this battery appears like this. In that you can see lead plate packed, okay, with a spongy lead oxide. Spongy lead means lead oxide, and lead plate packed with PbO2, and it is mixed with electrolyte 38% H2SO4. So lead oxide, lead oxide, lead oxide, they are alternatively connected. And this is how the electrolytic reactions takes place, you can see. So when the battery is in use means during discharge, so the cell reactions is PBS, overall reaction, okay, at anode PbSO4 dissolves to gives rise to PbO2, and at cathode PbSO4 is converted into Pb. So the overall reaction is Pb plus PbO2 in the dilute H2SO4 gives rise PbSO4. And when during recharge what happened, anode become cathode, cathode become anode, and the overall reaction is going to be reversed. That is the simplest trick you need to know with the NEET examination. So it's very simple, learn less and do more, है ना? Learn less and do more. समझे? Now let us talk about nickel cadmium battery. Nickel cadmium batteries we use in mobile phones and laptops, and instead of nickel cadmium nowadays lithium ion batteries are being used, and in this cadmium nickel hydroxide is going to get nickel dihydroxide and cadmium oxide and water. Nowadays nobody is using. Fuel cell. So hydrogen fuel cell is very important among them, and you can see in the fuel cell, I just want to give you, this is the fuel cell that used by Neil Armstrong when the Apollo space shuttle program is done by NASA. First human being landed their foot first time on the moon, and that machine, that project used this as a battery. Can you believe it? Can you believe it? अब से कैसे नोट करो, अब क्या करो? Okay, so उसमें होता है क्या? This is the cross section where potassium hydroxide is used as an electrolyte. Okay, इस type hydrogen, उस type oxygen, so that there is a combustion reaction. So combustion reaction का वजह से. So we are coming to the end of the session, my dear students. You please be active in the chat box. So at anode, hydrogen is reacted with alkali, that is used potassium hydroxide gives rise water, and at cathode oxygen and it oxidizes to gives rise OH. So the overall reaction is going to be hydrogen plus oxygen gives rise H2O. So that is the combustion reaction is converted into electrochemical reaction. This electrochemical reaction gives sufficient amount of the voltage can be used there. This is eco-friendly and do not give pollution as well. It's very important. Okay, and the overall reaction of hydrogen oxygen fuel cell is, who is going to give the answer? जल्दी देना चार्ट बॉक्स में, फटाफट चार्ट बॉक्स में फटाफट देना. इशिता, हाँ yes. Anamani, where is she? Abhinav, Suresh, Logamanayam, yes, side. So what is the overall reaction that is taking place? That's 3, Logamanayam, that's good. So that's our answer 3. So that we have just seen in the previous slide. Okay, Today we discussed it's a long journey. Everybody please be active in the class. It's a long journey. Galvanic cell, Nernst equation, okay, and concentration cell, single electrode potential, and standard single electrode potential, oxidation potential, reduction potential, EMF, Nernst equation, electrochemical series, standard hydrogen electrode, Faraday's laws, Faraday first law, second law, conductance, okay, specific conductance, molar conductance, equivalent conductance, Kohlrausch law, and we have seen the primary battery, secondary battery. Why not? A huge amount of content has been delivered, and this is the session notes we are going to get in the Infinity Learn, the Telegram channel in the PDF format, so that you all can enjoy the notes. So you study with this rapid fires, that therefore you can get an extremely good score. Okay, so doing great. Thank you very much for the session. Tomorrow we are going to see some more topic, like I think a solutions, it seems, right? So I'm going to show the overall chapter in 1 hour. Okay, take care, stay tuned, signing off, and meanwhile you just like and share and subscribe these sessions and YouTube channel. Thank you very much. Logvanayagam, bye Ishita, bye Suresh Kumar, bye Abhinav, bye. See you all the students, bye bye.